Hi guys, welcome to my YouTube channel. Myself Sachin Kumar I'm perceiving Sri Venkateshwara Engineering College in branch of Electronics and Communication Engineering. I am telling about application in low frequency generation using RC phase shifting oscillator. Introduction to RC phase shifting oscillator. The RC phase shifting oscillator is a type of electronic oscillator circuit that generates sinusoidal waveform. It is use a combination of resistor and capacitance to the creative phase shifting network that feeds back portion of the output signal to the input, creating positive feedback. Principle of low frequency generation phase shifting. The RC phase shifting network introduce a phase shifting 180-degree to the signal to describe oscillation frequency. Positive feedback. The amplifier provides an additional 180-degree phase shifting, ensuring the positive feedback and sustained oscillation. Oscillation frequency. The frequency of oscillation is determined by the values of resistance and capacitance in the phase shifting network. Advantages of shifting oscillator. Simplicity. The circuit requires a relative small number of components, making easy to build and implement. Easy tune. The oscillation frequency can be easily adjusted by varying the values of the resistor and capacitor. Low cost. The component used to are typically inexpensive, making it a cost-effective solution for low frequency generation. Practical applications of RC phase shifting oscillator. Timekeeping. Low frequency oscillators are the crucial accurate timekeeping in devices like clock watch and timers. Signal generation. They are used to create low frequency signal for applications such as audio oscillators, function generator, and medical equipment. Control system. RC phase shifting oscillator find used to control system where precious timing and low frequency oscillator are required. Design consideration low frequency generation. Resistor value. Choose resistor value and provide the desired phase shifting and ensure stability. Capacitor value. Select capacitor value based on the delay frequency range and the design time constant of the phase shifting network. Amplifier gain. Ensure the sufficient amplifier gain provide the necessary positive feedback for the sustained oscillation. Frequency stability and tuning capability. Component tolerance. Variation in component values can affect the stability of the oscillation frequency. Temperature effects. Temperature change can alter the values resistor and the capacitor influences of the frequency. Tuning machines. Variable resistor capacitor can be used to adjust the oscillation and frequency for the fine tune. Coupling and feedback mechanism. Coupling capacitor. A coupling capacitor is used to block DC bias from the amplifier and ensure that the only the AC signal transmit the phase shift network. Feedback resistor. A feedback resistor provides the necessary feedback to the amplifier, ensuring the a portion of the output signal and feedback to the input. Comparison with other oscillator topologies. Frequency stability. The RC phase shifting oscillator exhibit moderate frequency stability compared to the other oscillator topology. Circuit complexity. The RC phase shifting oscillator is relatively simple to the implement compared to more complex oscillator topology. Cost effectiveness. The RC phase shifting oscillator is typically cost effective due to the use of inexpensive components. Limitations and challenges in low frequency generation. Stability. Maintaining stability and avoiding unwanted oscillation can be changing especially at low frequency. The output waveform may exhibit destroy at the low frequency due to limitation in the amplifier and other component. Frequency drift. The oscillation frequency can be drift over time due to change the component value of environmental factor. Emerging training and future development. Minimization displacement in integrated circuit technology are leading to smaller and more integrated oscillator design. Digital control. Digital control techniques are beginning employed to enhance frequency stability, reduce the and improving tuning and capability.